In this problem, we're going to be taking a look at number 6 from the Projectile Motions Launched at Angles worksheet. Number 6 is a pitched ball is hit by a batter at a 45-degree angle, and it just clears the outfield fence, which is 98 meters away. Assuming that the fence is at the same height as the pitch, we're going to find the velocity of the ball as it left the bat. So as always, we're going to start with projectile motion, writing down our left and right things. We have our x stuff. The distance is 98. The cosine of 45 degrees times velocity is the velocity in the x direction here. And we do not know time. In the y direction, we know that it's going to land at the same height from which it was hit, so the distance in the y is 0. The velocity initial is the sine of 45 degrees times the velocity, because it's the opposite side of our triangle. And the acceleration, as always, is negative 9.8. Now, we don't have enough in either the x or the y directions to solve for time. So what we're going to need to do is write down our equation in the x direction and write down our equation in the y direction in order to find what it is that we're looking for. We're going to end up with a simultaneous equation that we're going to use to find v. We'll start in the x direction. In the x direction, we do know that distance equals velocity multiplied by time. And we're going to rearrange this for time to get distance over the velocity. When we plug in what we know, that would be 98 meters for our displacement, and the velocity is the cosine of 45 degrees multiplied by the actual velocity. We're going to do the same thing in the y direction. In the y direction, we're going to use our third kinematics equation, which is displacement equals initial velocity multiplied by time plus 1/2 acceleration times squared. And I'm not going to rearrange this equation. What I'm going to do is I'm going to take what I've found for time in the x direction and plug it in up here in our y equation everywhere we see a time. We can do this because it doesn't matter if we're looking at it in the x direction or the y direction, time is going to be equal. So when we do this, what our equation is going to look like is our distance in the y direction equals the initial speed multiplied by our 98 meters over cosine 45 degrees multiplied by the actual velocity of the ball, which is what we're looking for. Now we're going to do the same thing in the other term. We have our 1/2 times acceleration. And now t squared, we have to square everything, so that would be 98 meters over the cosine 45 degrees times v. And all of that would be squared. And that is what our equation is going to look like. What I'm going to do next is I'm going to plug in what I know initial velocity is, and I'm going to plug in what I know acceleration is, as well as the displacement. And we're going to get all of the numbers in here now. Now I'm going to move to another slide for this, and you can follow along as we go. So our equation, when I plug in all of my numbers, my distance was 0 meters. My initial speed in the y direction was the sine of 45 degrees multiplied by the velocity that we're looking for. And also up there, I had the distance in the x direction, which was 98 meters. In our denominator, we had the speed, the initial speed in the x direction, which was cosine of 45 degrees multiplied by v. In our other term, we have our 1/2. Our acceleration is negative 9.8 meters per second squared. And when I square what I've had in the parentheses, what I end up with is the 98 meters. That's in the numerator, and that gets squared. And in the bottom, I've got the initial velocity in the x, which is cosine of 45. That gets squared. So I get cosine squared times 45 multiplied by the velocity I'm looking for squared. I had to square all the stuff with the velocity and distance in the x direction. From here we can do some simplifying. My sine of 45 over cosine of 45 is going to turn into tangent of 45 degrees. And I have a velocity divided by a velocity, so those will cancel out. And I'm left with just the 98 meters. Over here in this right term, what might be a little bit easier is to multiply out the numbers that we have. So I can multiply the 1/2 and the negative 9.8 meters per second squared and the 98 squared. And when I do that, what I will end up with is a negative 47,059.6. And my units, I'm going to have meters multiplied by meters squared. So that would give me meters cubed. And I would have my second squared not canceling with anything, so second squared. Kind of a funny unit, but it'll start canceling out. And in my denominator, I still have my cosine squared 45 degrees multiplied by my velocity squared. Now what we can do from here, a little bit of algebra, and I'm going to move my tangent 45 multiplied by 98 over to the left. And now tangent 45, if you plug that in your calculator, you realize is just 1. So 1 times 98 is just 98. So moving my 98 over to the other side, 0 minus 98 is negative 98. That's now on the left side of my equal sign. On the right side, I'm just going to write what I had, which was negative 47,059.6 meters cubed per second squared. I have to keep my things in the denominator, which is cosine squared 45, multiplied by the velocity that we're actually looking for squared. Now I don't like fractions. We want to get rid of this fraction stuff. So I'm going to multiply my cosine squared 45 and v squared to the other side. So I'll get negative 98 meters multiplied by cosine squared 45 degrees times the velocity I'm looking for squared. And that's going to equal my negative 47,059.6 meters cubed per second squared. And now we're trying to solve for the velocity, so I'm going to get rid of my 98 and cosine 45. Move that back over to the right, make it a little bit easier there. And we will be left with just the velocity we want. And we just have to do the square root in order to find it then. So I'm going to move my 98 and cosine squared 45 to the other side. I get negative 47,059.6 meters cubed per second squared divided by negative 98 meters multiplied by cosine squared 45. And as I said, what we're looking to do is get rid of this squared. We don't want a squared, so all we have to do is take the square root of the other side. Square root. Plug all of that into your calculator, and what you should end up with is that the velocity of the ball as it leaves the bat is roughly 31 meters per second. And that is the end of number 6 from our projectile review paper.